Hey guys, this is going to be our first Unit 12 video. This is just going to be a basic trigonometry review, everything you should have learned in geometry as far as trigonometry goes. So we're going to start off real easy. We're going to start with the Pythagorean Theorem. Now remember, this is used to find a missing side length of a right triangle. If it is not a right triangle, that's not a pen. If it's not a right triangle, it cannot be used. So the formula here is a squared plus b squared is equal to c squared. So I'm sure that you know that. Remember that c is always the hypotenuse. It's not necessarily what you're always solving for, but C is always the hypotenuse. It's always the side across from the right angle. A and B are just the legs of that triangle. So here's an example down below. Okay, 24 is my hypotenuse because it's across from the right angle. And X, which I'm solving for, is one of the missing sides. So my equation is going to be X squared plus 22 squared equals 24 squared. It doesn't matter what my A and B are. The only thing that matters really is that I'm using 24 for the hypotenuse here. So I'm going to make some calculations. To get X by itself, I would have to subtract 22 squared from both sides. And then I would take the square root of that. So the reason I'm doing this before I get numbers is because if I do this, I can just type it all into my calculator in one swoop and get done quicker. So if we make this calculation, we find that X, if we just go out to the tenths spot, one decimal place, we find that X is equal to 9.6. So that's how you use the Pythagorean theorem. So that kind of just gets mixed in every now and then. We don't use it all the time, but it's very helpful if you have two sides of a right triangle and you need to know the third. So the other thing that you probably learned about in geometry were these trigonometric functions. We have sine, cosine, and tangent. Most likely you learned it by SOHCAHTOA. And this is just a helpful way to remember what sides go with which trig function. Now, all of these are based on the triangle that you see at the bottom. All of these are based on this angle theta. Okay, this is a Greek letter. It's called theta. If I drew an arrow, A would be my opposite side. B would be the adjacent side, and C would have to be the hypotenuse because it's across from that right angle. So when we're doing sine, cosine, and tangent, SOHCAHTOA is telling us which of these sides to use, the opposite side, the adjacent side, the hypotenuse. So sine is the opposite side over the hypotenuse. Okay. Cosine is the adjacent side over the hypotenuse. Tangent is the opposite side over the adjacent side. I'm going to rewrite this O because it looks horrible. So that's really what SOHCAHTOA is helping you remember. It's helping you remember which sides go with which trig functions. Now, what you probably didn't touch on were the reciprocal functions. So below each of the trig functions, sine, cosine, and tangent, you see a reciprocal function. Cosecant is 1 over sine of theta. So it's the reciprocal. It's taking that fraction and flipping it. So that means that cosecant, the CSC, is really going to be hypotenuse over opposite side. Secant is 1 over cosine, so it's the reciprocal of cosine, is going to be hypotenuse over the adjacent side. And cotangent is the reciprocal of tangent, which would make this the adjacent side over the opposite side. So if you can remember SOHCAHTOA, you got the top three, and then once you know the top three, the bottom three are really easy because you're just flipping that fraction. So let's find all 6 trig ratios for angle theta here. So notice that this is my opposite side, this is my adjacent side, and this is going to be my hypotenuse, but we don't have the length. We need to solve for the length. So to find that missing length, we need to use Pythagorean's theorem. So right now, I'm just going to label this side x. So to find x, we can use Pythagorean's theorem by doing x squared equals 30 squared plus 16 squared. So x is just going to be the square root of 30 squared plus 16 squared. So let's calculate that. The square root of 30 squared plus 16 squared gives us 34. So now I know that that hypotenuse is 34. So I'm going to erase this. We're going to write 34 here. That's what we are using for our hypotenuse. So now sine of theta we know is the opposite over the hypotenuse. So 16 over 34. Okay, and a lot of times you're going to be able to reduce these fractions. So whenever you can reduce, you should do that. Cosine is going to be adjacent over hypotenuse. So using the sides on our triangle, that would be 30 over 34, which is going to reduce to 15 over 17. Tan of theta is the opposite over the adjacent side, so 16 over 30, which reduces to 8/15. And then the 3 that are left here are the reciprocals of the 3 that we found. Cosecant of sine is the reciprocal, cosecant of theta is the reciprocal of sine theta, so it's going to be 17 over 8. Secant of theta is the reciprocal of cosine, so it's going to be 17 over 15. Cotangent is the reciprocal of tan, so it's going to be 15 over 8. And it's as simple as that. So let's look at one that's a little more confusing. We're going to find all 6 trig ratios for theta, but we don't have a triangle. The only piece of information we start with is that cosine of this angle theta is 2 over 3. So since we don't have a triangle, I'm going to draw one. And remember, it's a right triangle. Now, since I'm drawing this picture, I get to pick which angle that's left here is going to be my theta. So I'm going to pick this angle down here. We're going to say that this is theta. Now, if that angle is theta, this is my opposite side, this is my adjacent side, and this is my hypotenuse. Now, cosine is the adjacent side over the hypotenuse. We know for this problem that that's 2 over 3. So that means that our adjacent side must be 2, and our hypotenuse must be 3. So that just leaves the opposite side for us to find. So to do that, we're going to use Pythagorean theorem. X squared plus 2 squared is equal to the hypotenuse squared. So x is going to be equal to the square root of 3 squared minus 2 squared. Now, when we do this, we find that x is equal to the square root of 5. Please do not write this as a decimal. If you get a radical like this, just leave it as a radical. Break it down if it can be broken down. In this case, it cannot be. So let's go ahead and write square root 5, and we can start finding all of our trig ratios. So sine is opposite over hypotenuse, so radical 5 over 3. Tangent is opposite over adjacent, so radical 5 over 2. And then we have all of our reciprocal functions left. So 3 over radical 5, but we have to rationalize, which is going to make that 3 radical 5 over 5. Secant is going to be 3 over 2. And cotangent is 2 over radical 5. Again, if we rationalize, this becomes 2 radical 5 over 5. And there we go. Now, what we typically use sine, cosine, and tangent for is for finding missing side lengths. So we're going to do this for a couple problems. We're going to round to the nearest tenth for these. So we have an angle, a hypotenuse, and a missing side. So we're trying to find x. Now, the angle that we're given here is going to serve as our theta. So based on the angle, we want to decide which sides we have. We have the opposite side, and we have the hypotenuse. So you're asking yourself, does sine, cosine, or tangent work for opposite and hypotenuse sides? Okay, it's going to be sine. Sine of theta is equal to the ratio opposite over hypotenuse. So we're basically just substituting in what we know. Theta in this case is 64 degrees. My opposite side is unknown. My hypotenuse is 25. So to solve for x, I need to multiply both sides by 25 now. And here we go. So the first thing that you need to double check is that your calculator is in degree mode. So if you hit the mode button on your calculator, go down, you'll see radian and degrees. Make sure degrees is selected. And then we can go ahead and we can type in 25 times sine of 64. And that gives us, remember we're going to the nearest tenth here, x equals 22.5. So that is the missing side length. So let's see another here. Again, this angle that's given is going to be my theta. Based on this angle, this is my opposite side. This is my adjacent side. Okay, this side over here would be my hypotenuse, but we're not going to be using that for any reason. We're just going to use the opposite and adjacent side since that's our unknown and one of the side lengths that are given. So the opposite and the opposite and adjacent sides should indicate that we're using tangent here. Okay, tan of theta, which in this case is 47, is equal to the opposite over the adjacent side. So again, we can multiply by 12 on both sides here. And then we can go ahead and type it into our calculator. 12 times tan of 47 gives us 12.9. Now for this one, you've kind of seen it a few times now. We mark which sides we have. We have the opposite and the hypotenuse, so we can set it up. Okay, since we have opposite and hypotenuse, we know we're going to be using sine. So sine of 63 is equal to 27 over x. Now this is a little bit different here because our variable is in the denominator. So to get that out of the denominator, we need to multiply both sides by x. So we have x times sine of 63 equal to 27. And then we need to divide by sine of 63 on both sides. So x is equal to 27 divided by sine of 63. Okay, and we can type that into our calculator again. 27 divided by sine of 63 is going to give us 30.3. All right, one last one. Here's our theta. We've got the adjacent, the hypotenuse, so that's going to tell us that we're using cosine. So cosine of 30 degrees is equal to 18 over x. Okay, here's that situation where our variable is in the denominator again. So we're going to multiply both sides by x. And then to get x by itself, I'm going to divide by cosine of 30. And then we're going to type it into our calculator here. So let's see, 18 divided by cosine of 30 gives us 20.8. So this is how you use those trigonometric functions, or trig functions is usually how I say it, to help you find missing side lengths. Now, we can also use these to help us find missing angles. Okay? The only difference is we're looking for the angle. So we know that sine or cosine or tangent of a particular angle is equal to a specific ratio. We can use the inverse of these functions, not the reciprocal. A reciprocal is different than an inverse. We can use the inverse to solve for these angles. Now, consider this equation here. Sine of theta equals x. If we're solving for theta, then inverse sine would be taken of both sides. It would cancel with the sign on the left, leaving us with theta equal to inverse sine of x. So sine to the -1 power is what it looks like. On your calculator, if you hit second sine, that's what's going to give you the inverse. Okay, same for cosine theta. If I'm solving for cosine, or for theta here, I'm going to have to do inverse cosine to both sides, which will give me this. And for tangent, I would do inverse tan on both sides. So again, to access those, you're going to hit second sine, second cosine, second tangent, whichever one you need. That's how you access those on your calculator. So let's see how we use those. All right, for this one, we're going to label our sides based on angle theta. So 8's going to be my opposite side. 14 is going to be my adjacent side. Now, tangent is the trig function that uses those sides. So we're going to set this up as tan theta equals 8 over 14. So now to solve for theta, we need to do inverse tangent of 8/14. Let's round to the nearest tenth here. So theta is equal to 29.7 degrees. All right, let's look at another one. Okay, based on angle theta again, mark which sides you have. We have the adjacent side and the hypotenuse, so that's going to be cosine this time. Cosine of theta would be equal to 38 over 40. So we need to do inverse cosine to both sides, which is going to give us 18.2 degrees. Now, the last part of this basic trig review is going to be word problems. And whenever we're dealing with these word problems, you're almost always going to be given an angle of elevation or an angle of depression. So for an angle of elevation, okay, imagine you're standing there. This is your line of sight. This is a perpendicular horizontal. So this would form like a right triangle. The angle of elevation is going to be that angle between your line of sight and that perpendicular horizontal line. For an angle of depression, imagine you're looking down at something. So your line of sight is actually this one. Your horizontal perpendicular line from like your face is here, and this would form your right triangle. So it's kind of an upside down right triangle, but this would be your angle of depression. So it's gonna help you kind of draw your picture. I'm gonna draw some really bad pictures in this video here, but I always recommend drawing a picture of the scenario that you're trying to figure out, okay? All right, so for this first one, we have a fishing boat and a lighthouse. So I'm going to draw the lighthouse. It's going to be a very simple lighthouse. And we've got a boat out here. And let's draw some water just for fun. So the boat is looking up towards this lighthouse. Let me draw this a little bit better here. Okay, the lighthouse. Our triangle is going to be here. There we go. The angle of elevation would be this angle looking up from the boat to the top of that lighthouse. And we know that that's 5 degrees. Now, it says that the top of the lighthouse is 161 feet above sea level. So that means that this part is going to be 161 feet. And we're trying to figure out how far is the boat from the lighthouse, which would be this side right here. So we've got the opposite and adjacent sides of this triangle. So I'm going to set up tangent of 5 degrees is equal to 161 over x. So now I need to multiply both sides by x. I need to divide by tan of 5. And doing that is going to give me x equal to 1,840.2 feet. So that's how far away the boat is from the lighthouse. So it's all about drawing a picture. Just know that your picture is going to have a right triangle in it. It wouldn't work if it didn't. Okay. So let's look at another. Okay, again, the angle of elevation from the bottom of a slide to the top of a slide is 44 degrees. So we have a basic triangular slide here. Imagine this is your ladder, this is the actual slide, and this is just the other leg of the triangle that makes. So the angle of elevation from the bottom of the slide to the top would be this angle here. So it's telling us that that angle is 44 degrees. It tells us the top of the slide sits 16 feet above the ground, so that would be this side. And we are looking for the length of the slide. Now, the part that you actually slide on would be the hypotenuse in this case. So we're looking for this. So again, what sides do we have? We have the opposite, we have the hypotenuse, so that's telling us that we're using sine here. So sine of 44 is equal to 16 over x. Multiply both sides by x now. Divided by sine of 44. And when we calculate this, we are going to get that the slide is 23 feet long. So once you get your picture set up, it's really pretty easy calculations. All right, another one here. So it says a fire is spotted from the top of a 125-foot tall fire tower. So here's our tower. Okay, and let's say it's looking down and it sees the fire right here. So, oh, that was a horrible line. Let's try that again. Okay, it's looking down, down. There we go. That's better. So we are looking at this red right triangle. Now that's kind of what's modeling this situation. We know that the tower is 125 feet tall, so that would be this side over here. By the way, when I do this one little dash, this just means feet. If there were two, it would mean inches. So 125 feet tall. We know the angle of depression is 19 degrees. Now, an angle of depression, remember, is different. An angle of depression gives us really like a flipped over triangle compared to this. So I'm going to draw this in blue. So really, angle of depression would be setting up a triangle like this. We're looking down from the tower to the fire. So this angle is the angle of depression. So that's 19 degrees. Now, this 125 that I had over here, that's really the same as this right here. And we're trying to figure out how far away the fire is from the base of the tower, which would be this distance, or in the blue triangle, it's going to be this one up here. So based on our angle of depression right here, we have the opposite side and we have the adjacent side. So we can set up our calculation. We're going to be using tangent. So tan of 19 degrees is equal to 125 over x. Now, you've probably noticed when we get in this situation, I multiply by x, I divide by tan, so they really just flip spots here. So x is equal to 125 divided by tan of 19. And let's calculate that here. Okay, that gives us 363 feet. So that's how far away the fire is from the base of the fire tower. Okay, one last one with an angle of depression. So we've got an airplane, it's flying over water, it's looking down from the plane into the water, and they see a raft. So angle of depression, I'm going to draw a really bad plane here. There we go. So there's our plane. Now the pilot is looking down into the water, so the water's down here. Okay, let's say there's a raft right about here. So they're looking down. They see that raft. Remember, since it's an angle of depression, our triangle is going to be flipped over. So this is our angle of depression, which they tell us is 28 degrees. We know that the plane is 8,900 feet over the water, which would be this side, and we're trying to find the horizontal distance from the airplane to the raft, which would be this side here. So we have the opposite, the adjacent side again. We're going to be using tangent. So tan of 28 is equal to 8,900 feet over x. So x is equal to 8,900 divided by tan of 28. And when we make that calculation, let's see what we get here. We get 16,738.5 feet. All right, guys, I know that was a lot of different stuff, but you should have already seen this in geometry. So hopefully you feel pretty comfortable. Let me know if you have any questions, and have a great day.